Hypothesis tests for one population mean when sigma is unknown. One mean t-test. Purpose: to perform a hypothesis test for a population mean mu. Assumptions: 1. Simple random sample. 2. Normal population or large sample. 3. Sigma unknown. One mean t-test. For the one mean t-test, we have 6 steps. The first 3 steps are the same whether we use a critical value or a p-value. Step 4 and 5 differ if you use the critical value versus the p-value. Step 6 is the same for both. Step 1. The null hypothesis is h0 colon mean equal mean sub 0, and the alternative hypothesis is h colon mu does not equal mu sub 0 two-tailed, or h colon mu less than mu sub 0 left-tailed, or h colon mu greater than mu sub 0 right-tailed. Step 2. Decide on the significance level alpha. Step 3. Compute the value of the test statistic and denote that value t sub 0. T equals x bar minus mu sub 0 divided by s divided by the square root of n. One mean t-test using critical values. Step 4. The critical values are plus or minus t sub alpha divided by 2, two-tailed. Our t distribution has 2 critical values, negative t sub alpha divided by 2 and positive t sub alpha divided by 2. Alpha is divided into 2 areas. Alpha divided by 2 is the area to the left of negative t sub alpha divided by 2, and alpha divided by 2 is the area to the right of t sub alpha divided by 2. Reject h sub 0 when the test statistic is to the left of negative t sub alpha divided by 2 or to the right of t sub alpha divided by 2. Do not reject if the test statistic is between negative t sub alpha divided by 2 and t sub alpha divided by 2. Or negative t sub alpha left-tailed. On the t distribution, negative t sub alpha, the critical value, is to the left of 0, the mean. The area to the left of negative t sub alpha is shaded, and that's alpha. If the test statistic is less than negative t sub alpha, reject h sub 0. If the test statistic is larger than negative t sub alpha, do not reject h sub 0. Or t sub alpha, right-tailed. T sub alpha, the critical value, is to the right of 0, the mean, on the t distribution. Alpha is the shaded area to the right of t sub alpha. If the test statistic is larger than t sub alpha, reject h sub 0. If the test statistic is smaller than t sub alpha, do not reject h sub 0. With degrees of freedom equals n minus 1. Use the t distribution table to find the critical value or values. Step 5. If the value of the test statistic falls in the rejection region, reject h sub 0. Otherwise, do not reject h sub 0. Step 6. Interpret the results of the hypothesis test. One mean t-test using p-value approach. Step 4. The t-statistic has df equals n minus 1. Use the t-distribution table to estimate the p-value or obtain it exactly by using technology. For a two-tailed test, our p-value would be the sum of the area to the left of negative t sub 0 and to the right of t sub 0. For a left-tailed distribution, the p-value would be to the left of t sub 0. For a right-tailed distribution, the p-value would be to the right of t sub 0. Step 5. If p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. Step 6. Interpret the results of the hypothesis test. Note, the hypothesis test is exact for normal populations and is approximately correct for large samples from non-normal populations. Example using critical values. A sample mean, sample size, and sample standard deviation are provided below. Use the one mean t-test to perform the required hypothesis test at the 1% significance level. X bar equals 22, S equals 6, N equals 32, H sub 0, colon, mu equals 23, H sub A, colon, mu less than 23. Step 1. Determine if we have a left-tailed, right-tailed, or two-tailed test. Since H sub A has a less than symbol, we have a left-tailed test. Next, we want to draw a sketch of what that looks like. Since it is a left-tailed test, I want to find negative t sub alpha. Alpha is the area to the left of my t-score, and that is also my rejection region. Step 2. Decide on a significance level alpha. In the original problem, we were told it was a 1% significance level. That means alpha equals 0.01. Step 3. Compute the value of the test statistic and denote that value t sub 0. In order to find t sub 0, we have to use our formula for the test statistic. T equals x bar minus mu sub 0 divided by s divided by the square root of n. Substituting, I have 22 minus 23 divided by 6 divided by the square root of 32. We need to remember when we substitute this into our calculator that we need parentheses around the numerator and parentheses around the denominator. So to calculate, parenthesis 22 minus 23, close parenthesis, divided by 6 divided by the square root of 32. I've forgotten my parenthesis, so I'm going to arrow to my left. When I'm over the 6, second insert, open parenthesis, then I'm just going to arrow to the very end of my square root 32, close parenthesis. I want to make sure the last parenthesis isn't a part of the square root. Enter, and then rounding to 2 decimal places, I have negative 0.94. The test statistic is t equals negative 0.94. Step 4, identify the critical value. First, I need to know my degrees of freedom. 32 take away 1 is 31. Now I need to find negative t sub alpha. Since alpha is 0.01, I want to find negative t sub 0.01. I need to use my table for this. My degrees of freedom are 31, and my alpha is 0.01, so the t-score is 2.453. Since it is left-tailed, I want to use negative 2.453. The critical value is negative t sub alpha equals negative 2.453. Step 5. If the value of the test statistic falls in the rejection region, reject h sub 0. Otherwise, do not reject h sub 0. So I want to label on my sketch negative 2.453 is our critical value, and negative 0.94 is our test statistic. Since our test statistic falls to the right of the critical value, it is in the do not reject H sub 0 region. Do not reject H sub 0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. The data do not provide sufficient evidence to conclude that the mean is less than 23. Example using critical values. Alligators perform a spinning maneuver referred to as a death roll to subdue their prey. In a study of alligator death rolls, one of the variables measured was the degree of the angle between the body and the head of the alligator while performing the roll. A sample of 20 rolls yielded the data provided below in degrees. At the 1% significance level, do the data provide sufficient evidence to conclude that on average, the angle between the body and the head of an alligator during a death roll is greater than 48 degrees? Note, X bar equals 49.81 degrees and S equals 10.465 degrees. Preliminary data analysis indicated that you can reasonably use a t-test to conduct the hypothesis test. We know our sample mean and sample standard deviation as given in the problem. Next, we need to find our sample size, n equals 20. Next, we want to find our significance level, which is 1%. Step 1. Find H sub 0 and H sub A. The preliminary data said that on average, the angle was 48 degrees. So H sub 0 is mu equals 48. Now we want to find H sub A. What we are trying to conclude is that the angle is greater than 48 degrees. H sub A is mu greater than 48. Now that we've gathered that information, we're ready to decide, as a part of step 1, if we're dealing with a left-tailed, right-tailed, or two-tailed test. Looking to H sub A, we have greater than. Greater than always gives us a right-tailed test. So the rejection area is the area to the right of T sub alpha. Step 2, decide on the significance level alpha. Our significance level is 1%, so alpha equals 0.01. Since we are using critical values, we are going to compare our critical value to our standardized test statistic. So step 3, we want to compute the value of the test statistic and denote that value T sub 0. When we are looking for a test statistic, we want to use our formula. T equals X bar minus mu sub 0 divided by S divided by the square root of n. Substituting, I have 49.81 minus 48 divided by 10.465 divided by the square root of 20. We want to calculate, parenthesis, 49.81 minus 48, parenthesis, divided by, parenthesis, 10.465 divided by the square root of 20, parenthesis, enter, so it equals 0.77. The test statistic is T equals 0.77. Step 4, identify the critical value. This is where we find T sub alpha. My degrees of freedom is 19 since n equals 20. So T alpha will be T sub 0.01. Go to our table. Our degrees of freedom are 19 and alpha is 0.01. So our t-value is 2.539. Since it's a right-tailed test, we want positive 2.539. The critical value is T alpha equals 2.539. Step 5. If the value of the test statistic falls in the rejection region, reject H sub 0. Otherwise, do not reject H sub 0. Looking at our sketch, we want to figure out where our test statistic and our critical value belong. My critical value is 2.539. The test statistic is 0.77, which is smaller than 2.539. The test statistic falls in the non-rejection region. Do not reject H sub 0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. The data does not provide sufficient evidence to conclude that the average angle between the alligator's body and its head is greater than the hypothesized mean. Example using p-values. A sample mean, sample size, and sample standard deviation are provided below. Use the one mean t-test to perform the required hypothesis test at the 1% significance level. X bar equals 32, S equals 8, N equals 15, H sub 0 colon mu equals 25, H sub A colon mu is greater than 25. Step 1. Determine if we have a left-tailed, right-tailed, or two-tailed test. Since H sub A has greater than, we have a right-tailed test. Next, we want to draw a sketch of what that looks like. My critical value, T sub alpha, is positive, and alpha lies to the right of T sub alpha. Step 2. Decide on the significance level alpha. In the original problem, we are told that we have a 1% significance level. Changing that percentage to a decimal, alpha equals 0.01. Step 3. Compute the value of the test statistic and denote that value T sub 0. To find the test statistic, we need to use the formula T equals X bar minus mu sub 0 divided by S divided by the square root of n. Substituting, we have 32 minus 25 divided by 8 divided by the square root of 15. Going to our calculator, parenthesis 32 minus 25, close parenthesis, divided by, open parenthesis, 8 divided by square root 15, parenthesis, parenthesis, enter, and this rounds to 3.39. The test statistic is T equals 3.39. Step 4. The T statistic has df equals n minus 1. Use the T distribution table to estimate the p-value or obtain it exactly by using technology. Degrees of freedom are 14 because n is 15, and the test statistic I found is T equals 3.39. Go to my calculator, second distribution down to T CDF, enter. Since it is a right-tailed test, my lower limit is 3.39, and I need my upper limit to be a really big number. I chose 10,000. Then I want my degrees of freedom to be 14. Enter. And if you do not have the stat wizard, this is how you would type it in. You'd have TCDF, you would type in your lower limit, 3.39, comma, your upper limit, a large number, comma, degrees of freedom, 14. Enter. And this gives us 0.002. So P equals 0.002. Step 5. If P is less than or equal to alpha, reject H sub 0. Otherwise, do not reject H sub 0. 0.002 is less than 0.01. That means that the p-value is less than 0.01. Reject H sub 0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. The data provide sufficient evidence to conclude that the mean is greater than 25. Example using p-values. The ankle brachial index, ABI, compares the blood pressure of a patient's arm to the blood pressure of the patient's leg. A healthy ABI is 0.9 or greater. In a study, researchers obtained the ABI of 187 women with arterial disease. The results were a mean ABI of 0.89 with a standard deviation of 0.15. At the 10% significance level, do the data provide sufficient evidence to conclude that, on average, women with arterial disease have an unhealthy ABI? First, we want to find our sample mean and sample standard deviation. We get that from the results. X bar equals 0.89, S equals 0.15. Next, we want to find our sample size. In the study, they used the information of 187 women. N equals 187. We have a 10% significance level, and our significance level is 10%. Step 1, find H sub 0 and H sub A. So the mean was 0.9. H sub 0 is mean equals 0.9. Now we want to find H sub A. Since a healthy ABI is 0.09 or greater, an unhealthy ABI would be less than 0.9. H sub A is mu less than 0.9. Continuing with step 1, we want to decide if we have a left-tailed, right-tailed, or two-tailed test. Since H sub A is less than, we have a left-tailed test. This means the area for the p-value will be to the left of our test statistic. Step 2, decide on the significance level alpha. Since our significance level is 10%, alpha is 0.10. Step 3, compute the value of the test statistic and denote that value T sub 0. Test statistic means formula. T equals X bar minus mu sub 0 divided by S divided by the square root of N. Substituting, we have 0.89 minus 0.9 divided by 0.15 divided by the square root of 187. Calculating, I start with parentheses, 0.89 minus 0.9, close parenthesis, divided by parenthesis, 0.15, divided by the square root of 187. Closing parenthesis, enter, equals negative 0.91. Rounding to 2 decimal places, T equals negative 0.91. The test statistic is T equals negative 0.91. Step 4, the test statistic has degree of freedom equal n minus 1. Use the t-distribution table to estimate the p-value or obtain it exactly by using technology. We need to find the area to the left of our test statistic. Since n equals 187, our degrees of freedom are 186, and t equals negative 0.91. Going to our calculator, second distribute, we want T CDF, which is 6. Since this is to the left, we want our lower limit to be a really small number. I'm going to use negative 10,000. And our upper limit is going to be our test statistic, which is negative 0.91. Make sure you use the negative button and not the minus sign. Our degrees of freedom are 186. To enter, and my answer is 0.182. So this gives us a p-score of 0.182. Now we want to compare our p-score to our alpha. Step 5. If p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. Comparing our p and our alpha, 0.182 is greater than 0.1, which means the p-value is greater than 0.10. Do not reject h sub 0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. The data do not provide sufficient evidence to conclude that women with arterial disease have an unhealthy ABI. To recap the section, hypothesis test for one population mean when sigma is unknown. One mean t-test. Step 1, we find the null and alternative hypothesis, then decide if we have a two-tailed, left-tailed, or right-tailed test. Step 2, decide the significance level alpha. Step 3, compute the value of the test statistic. At step 4, we need to decide if we're going to be using critical values or using the p-value approach. Step 4, using critical values. Using alpha, we find the t-value that corresponds to it. If it's a two-tailed test, it's plus or minus t sub alpha divided by 2. Left-tailed, negative t sub alpha, right-tailed, t sub alpha. And then step 5, if the value of the test statistic falls in the rejection region, reject h sub 0, otherwise do not reject h sub 0. Using the p-value approach, using the test statistic with degrees of freedom n-1, we then find the area that corresponds to the test statistic. Once we find the area, if it's a two-tailed test, p equals 2 times the area. If it is a left-tailed test, p equals the area to the left of our test statistic. And if it's a right-tailed test, p equals the area to the right of our test statistic. Step 5. If p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. For both Step 6, interpret the results of the hypothesis test.